Hello again, physicists. A quick video for you today. We're just going to do a compare and contrast on what are called perfectly elastic and perfectly inelastic collisions. So let's start. First off, a perfectly elastic collision is a collision of bounciness. So yes, when we are looking at scenarios where there is a bouncy interaction, really, that is an example of a elastic collision. Now, not all bouncy collisions are perfectly elastic. In fact, there's no example in nature where you really have an ideal elastic collision. But bouncy situations are similar to a perfectly elastic scenario. In a perfectly inelastic collision, this is what we already know as the sticky situation, where two things are colliding and then together they move as one object because they're stuck together. Now here's what's really happening. In a perfectly elastic collision, you have the kinetic energy of the objects conserved. So not only do you have momentum conservation, but you also have energy conservation. Whereas in an inelastic collision, you do not have a conservation of energy. Now, where does some of that kinetic energy go if it's not conserved? Well, it's going to be lost to things like noise, sound waves, heat, and work that will permanently deform something. If you think about a car crash where both vehicles end up being stuck together, they are both permanently deformed in some way. Work was done on them, and they lost their kinetic energy partially because of that. So we're going to take this idea that energy can be conserved in some collisions, and what it will do is it will essentially give us a second formula, where we can say that the sum of the kinetic energies initially will be equal to the sum of the kinetic energies after a collision occurs. And this, along with our conservation of momentum concepts, will allow us to solve some fairly complicated problems. And we'll get more into detail with, what would these problems look like tomorrow. So until next time, physicists, until next time.